This is the 1.3 domain and range, increase, decrease, and piecewise practice that you guys did for 1.3. I'm just going to go through several of these with you. But as we're going, guys, if you have questions, stop me. Say, hey, I don't understand this. How did you get this? That sort of thing. If you want to turn your cameras off, you're more than welcome to, but you don't have to. But I'm actually going to turn mine off just because, you know,
Miss Meadows?
my head. What's up?
Looking at the quiz, it says that 1.8 is also included.
Right. Since we had like a little bit of a glitch yesterday with everything, we're not going to get as far as we wanted to. So I'm going to take 1.8 off.
All right.
Yeah, that's why I was letting you guys know that now. Hold on. Okay. Okay. All right, so in this case, guys, it says to approximate. I know that. So I'm just going to approximate so we don't have to just go back and forth and guess which we're talking about here. I'm going to approximate that this point right here, this lowest point, is going to be negative 1.2. And I'm going to say this one is positive 1.2. Okay, just for the purpose of being able to have specific starting and stopping points. Is everybody okay with that? I'm also going to approximate that this right here is going to we'll say negative 0.5. It's easier for our computing purposes to have some sort of specific points for you guys to look at. So the first thing we're going to talk about, domain and range, right? Let's give ourselves some notes. What's going on here? Let's give us guys some notes so we have stuff to refer to. Domain is X values, correct? And we read from left to right. Everybody agree? Our range is our Y values. And we read from bottom to where?
To top.
Good. Mm-hmm. And then our intervals of increase, decrease, and constant. You guys did a really good job with this yesterday. We read on what axis?
The x-axis.
Good. Read on x-axis. And we always use parentheses for notation. No matter if it's closed dot or open dot or anything like that, you're always going to use parentheses. Another thing we might want to remember is if we have a closed dot somewhere, that includes that value, and we use brackets. And if we have an open dot, it does not include. And that's parentheses. That's for our domain and range. Okay? Remember that? We're good? Okay, can you guys see this screen okay?
Yes.
Okay, I don't know why it's sideways like that, but sorry. All right, so the first thing we're going to identify is the domain. Domain is our X values. I have specific starting and stopping points. I can see that this has a specific place that it starts and a specific place that it stops. So on the left-hand side of the graph, I'm going to go down, and on the x-axis is where we read domain. So this graph starts at what?
-2.
-2, and it goes all the way over to what?
+2.
+2. And what am I going to have on each end? Bracket or a parenthesis?
Bracket.
Why?
Because the dot is filled in.
Thank you very much. Good job. All right, now we're going to talk about range. We read...
Can you go back up a little bit, please?
Sure.
A little bit. Didn't finish writing it down.
Mm-hmm. We read range from bottom to top.
Thank you.
Sure, no problem. So where is the lowest part that this graph goes?
To the 0.5.
Okay, so -0.5.
Well, I put that as -0.2.
That's fine. That's fine, yeah, because we're just approximating. I just made it an absolute right now for us so we can have something that we all reference. And then what's the highest value that it goes to?
8.
8, okay. And what is going to go on both ends of that?
Brackets.
Brackets as well. Because down here at the 0.5 or 0.8 or whatever you said it was, 0.2, this point exists. It's not written as a point, but it exists because it's on the function. So now when we do increase and decrease, what did I tell you was the most important thing to do before you even start trying to read it?
Cross out the y.
Cross out the y stuff. Because the first thing my C period did when we did this, when I said, okay, the first part is decreasing, they said it was decreasing from 8 down to, that negative 0.5. And that's not right because that's the y-axis. We read intervals of increase and decrease on the x. So I'm going to start here. And I tell you guys to follow.
Wait, I'm sorry, Miss Meadows. I have a question.
You're fine.
For the negative 0.5, so since closed circles you say need brackets, why is the negative 0.5 in brackets if there's no circle on it?
Because right here, where this comes down, it's a good question. This comes down here. My iPad's just not working for me really well today. Okay, so this comes down. Do you guys agree with me? Hold on. How this graph in the blue comes down, the furthest that it comes down is in line with right here. You see that? Like this part of the graph, that's as far down as it comes?
Yes.
Okay, so where this graph is, that happens to be a point. It's just not it's not written out like a big dot because it exists right here on this curve. So it's not that this would be an open dot that there was nothing there. Like there's actually points all along this area. That's what makes up this curve, or just a bunch of points all stuck together.
Okay.
Like there's a point right here. You don't see it because it's written as like a continuous line, but there's a point. Anywhere that you see this blue, there's a point there, there's one there, there's one there, there's one there, there's one there. There's points. All of this function that gives it its shape is made up of a whole bunch of points. Does that make sense?
Okay.
No?
So, but like, why isn't it an open circle then?
Because it's something actually exists there. That point is included because it's on the line.
So if it was a point that wasn't on the line, then it'd be
Open. Correct. If there was like a space there, if the graph didn't exist there, then yeah, that would be open.
Okay.
All right, so as we read increase and decrease, okay, we're going to read increase and decrease. I'm going to come down this way. I'm decreasing, correct?
Yeah.
Okay, so I'm decreasing over the interval of what on the x-axis to what on the x-axis?
-2 to -1.2.
Yep, or whatever you made that dot to be. It may not be -1.2. That's okay. Then I'm going to go from this point. And I'm going to follow, and I'm going to go this way. What am I doing when I'm going from this point up to the top of that curve? What am I doing?
Increasing.
I'm increasing. So remember, we look on the x-axis. I'm increasing from where on the x-axis to where on the x-axis?
From 1.2 to 0.
From -1.2, good, to 0.
Like,
From -1.2 to 0, good. So then I'm going to take my pencil again, and I'm going to say, okay, from this point here, I go down. What does down mean?
decrease.
Decrease. You can either write a new decrease if you want to, or you can put it up next to this one up here, and it's fine, it doesn't matter. But from where on the x-axis to where on the x-axis?
0 to 1.2.
Perfect, good. And then from here, this point, I'm going up. What does that mean?
Increasing.
Increase. Again, you can do you can do a new increase, you can do it next to the old one, but from what point on the x-axis to what point on the x-axis?
From 1.2 to 2.
Perfect. That's probably the hardest type of one that you're going to do when it's going up and down like that and the intervals are so tiny. But the biggest thing to remember is that your intervals of increase and decrease only have to do with the x-axis, not the y's. It's not from 8 down to negative something and then back up to 2. And it's not the y-axis. It's only the x. Does that make sense? A little bit? Okay, let's look at this one. We're going to do a few of these together so we kind of get the hang of it. How is this different from the last one we did?
It has arrows.
Mm-hmm.
It keeps going. Like
Because of the arrows, it just keeps going, right? Okay. So again, I'm going to just name this point here on the, let's just say this is 0.5. Like on the x-axis. Well, let me put it down here. Not 0.5. Yeah, we'll just say this is negative 0.5 again. Just for computational reasons. You guys do whatever you want. So remember, this is negative infinity over here. This is positive infinity over here. I'm putting the infinities because we have arrows. Arrows means it goes on forever and ever and ever and ever and ever and ever and ever, right? So as I'm talking about domain and range, this function is going to forever get wider. It's going to forever extend on both ways. So what is my domain for a function that is going to forever extend in both directions?
Negative infinity to infinity.
Perfect. My domain is going to be negative infinity to positive infinity. Good. Now, if it's forever in both directions going to get wider, the arrows are going in opposite directions, so it's going to forever get what for the range? It's going to keep...
So negative infinity to
Yep,
positive
negative infinity to positive
Oh.
infinity. It's going to go in the opposite directions forever and ever and ever and ever and ever. Now, our intervals of increase and decrease, remind me again, guys, I don't need the y values, so cross them out. You don't want to get yourself confused. So if I start up here, because I always read from left to right, I start up here and I'm coming down. Where am I starting from on the x-axis since I have arrows and it's way up at the top?
So I guess from like negative 4.5.
No, where am I starting from?
Oh,
I see what you're saying, but why is it going to be negative infinity?
because it keeps on going.
Correct. So I'm starting out here at negative infinity and I'm going downwards. So that's a decrease, agreed? So negative infinity to where on the x-axis?
To negative 3.
Perfect. Now I'm going to say, okay, let me follow what the next thing does. I go here and I'm going upwards. What does it mean when I go up? What do we call that?
You increase.
I increase. Fantastic. I'm increasing from where on the x-axis to where on the x-axis?
From negative.
I'm sorry, Mr. Molina and Miss Lovett, we're saying hello. From where? Negative 3 to?
Negative 3 to negative 0.5.
Perfect. And then I'm going to go and follow what the next line does, the next piece. And I'm going to come here, and I'm going to go, it's doing what?
A decrease.
It's a decrease. Okay, here, be careful here. It's decreasing from where?
From
Negative 0.5 to what?
To infinity.
Very good. Why'd you say positive infinity and not negative infinity?
Because it's the x-axis.
Because it's the x-axis. Fantastic. I know, guys, it's going downwards, but that doesn't matter because remember, we're reading on only the x-axis. Good job. Very good job. How do we feel?
Better.
Diener, is that you answering all these questions?
I only
No,
have 2.
No, I know. Because I can't see you guys, though.
My camera should be on.
I can see you, but I can't see most other people. And my screen is... Why is this going to be super easy to do?
Because it's not going on forever. And
It's not going on forever and ever and ever and ever. It also
only got,
has...
like,
Go ahead, I'm sorry, Vincent.
Oh, sorry. And it's only got like one increasing and one decreasing.
Right, one increase, decrease. And look, it switches directions at like a specific point. This would be super good for us to do. Let's talk about domain. My domain is from the left-hand side to the right-hand side. Where do I start on the left-hand side? At what number?
From 1
1 to what?
to 5.
To 5. Perfect. And what's going to go on either end of that?
Right.
Perfect. Good job. All right, my range. What's the lowest that this graph goes?
Negative 6.
And what's the highest that this graph goes?
Positive 3.
Perfect. And what's going to go on both ends?
brackets because they're both existing points.
They both are existing points. Fantastic. So now we're going to do our increase, decrease constant. And I'm going to, first things first, cross off the y. Nobody cares about the y. I mean, we always care about y, but you know what I mean.
X is where it's at.
Say it again.
X is where it's at.
Yes, x is where it's at. You're right. All right, so I'm going to start here on the left-hand side, and I'm going to follow this function, and it's going in which direction?
It's decreasing.
It is decreasing. So it's decreasing from where on the x-axis to where on the x-axis?
From 1 to 3.
Perfect. Good job, guys.
Yeah.
All right, now I'm going to go where we switch directions, and I'm going to go this direction. What am I doing? Going which way?
Increasing.
I'm increasing. Fantastic. And we're increasing from where to where?
3 to 5.
3 to 5. Perfect. Are you guys seeing this a little better than we did yesterday?
Yeah.
Okay, good.
Yeah.
That's
When you're doing stuff like this, guys, you can't just look at it. You have to actually write all over whatever you're doing. It makes it so much easier. I know it's kind of a pain sometimes to write extra stuff, but it's really important that you write down arrows and cross stuff off so you can actually physically see what you're looking at. Like in this one, let's go quickly. We got this. Domain. From where to where?
2 to 7.
2 to 7. What's the notation?
Bracket.
Awesome. Range. Bottom to top.
-6 to -1.
Woo! -6, -1. What are the notations?
Brackets.
Awesome. All right, increase, decrease. Cross off the y. Because Deanna, x is where it's at. I'm going to start saying that now. All right, left-hand side. I'm going to go, and I go, whoop. It sounds cooler, too, if you do sound effects.
It increases from 2 to 4.
Hold on one second.
Oh, I thought the connection died for a second.
No, it's just I was answering something in a chat. Okay, so I'm sorry. It increases, we said, from where on the x-axis to where on the x-axis?
From 2 to 4.
To 4. Awesome. And then
Decreasing from 4 to 7.
it decreases. I can't even keep up with you guys. You're going so fast. Decrease. Good. From 4 to 7. Superstars. Awesome. How do we feel?
Good.
Okay, good. I like to hear it. All right. I'm going to skip these. Let's go to the next page. I want to do one more. Look at what I did on number 8. Your number 8 looks a little different from my number 8. Anybody see the difference?
I think it's the
The
not
constant.
filled in dot at the
Right.
end.
The open dot, yeah. So go ahead, make that change. Or when I'm in the middle of explaining this, you guys, someone will say, wait a second, my dot looks different. I'm going to say, I just told you why. But that's okay. I just didn't have any. I realized when I made this PDF, I realized that I didn't actually put any that had any open. So, all right, so let's go. We're going to do domain and range first. And we're so good at this. Domain. What's the furthest left we go and then the furthest right?
-7 to 2.
-7 to 2. What notation do I have where?
Bracket on the -7, parenthesis on the 2.
Perfect.
Yeah.
Somebody explain to me why.
Because the -7 is a filled in dot and the 2 has an open dot.
Perfect. And then our range is going to go from the lowest point to the highest point. So it's what to what?
0 to 7.
0 to 7. And both of those have brackets because they both are existing points on the function itself. Good. So now we're going to do our increase, our decrease, and our constant. I'm going to start over here on the left. Oh, what did I forget to do?
Cross off the y.
Cross off y's. Bye, y.
Got it?
Say bye, y.
Bye.
All the silly stuff that I say, guys, it's not just because I'm goofy. It's because a lot of times when I say dumb stuff and then you think about, like, as you're doing it, you'll be like, oh, remember when she said bye, y? That's good. You need to remember that stuff.
Mr. High used to do that.
Well, because he's goofy like I am, so it's good.
Yeah.
All right, left-hand side. We're going to go here, and we're going to go which direction?
Increasing.
We are increasing. Very good. I'm increasing from where on the x-axis to where on the x-axis?
-7 to -4.
-7 to -4. And what kind of notation do I have on either side?
It's always parentheses. 'cause
Very good.
it's increasing.
Good job, Vincent. How's your sister doing?
She's doing good.
Miss Ferrier just came in, so tell her that Miss Ferrier said hello.
Okay.
Vincent Hahn.
Oh,
He's right down here.
I have your
Hold on.
cousin.
How many Hans are there?
I don't know.
Okay, so what's happening here, folks? From
It's remaining
this point to this point, it's doing what?
It's staying the same.
It is staying the same. What do we call staying the same?
Constant.
Constant. Awesome. So it's constant from where?
-4 to -1.
Perfect. Perfect, perfect, perfect. Oh, my biggest decision is what color am I going to use? Now I go here and I go downward. What do we call downwards?
Decreasing.
Decreasing from where on the x-axis to where on the x-axis?
-1 to 1.
-1 to +1. Fantastic. And then this last little piece, what's it doing?
Increasing.
It's increasing. So it's increasing from where to where?
1 to 2.
You see where I wrote it there? I could have also wrote increasing down here. It does not matter. If you have a multiple choice test, you'll probably see it written. Hold on. You'll probably see it written like this with the increase together, but it's all the same. You guys can see that. All right, how do we feel?
Good. Pretty confident.
Okay, good.
Can you do number 5? Because I don't really get it.
Sure, hang on one second because my screen froze for the 13th time today, so hang on. Okay, the bottom two piecewise functions, you guys were like, what? Okay, they were hard. I know they were hard. I put them on there just to be a little challenging. But some of you were asking me, and I guess last year I talked to Ms. Glick and to Ms. Boyd. Some of you, I guess when you did piecewise, you were given the X values to use. We're probably not going to give you the X values to use. You guys got to kind of figure that out on your own. But some of you asked, do I just make an XY chart or where do I get one? And I just said, well, just make it. Pick whatever numbers you want. That's okay. But let's do these two together. Let's talk about these two, and then we'll go over some 1.1, 1.2 stuff from your homework that I didn't get a chance to touch on. And then we'll start 1.5 tomorrow. Not today. Okay. I'm going to use two different colors. I'm going to use this pretty pink. And I'm going to use this, I don't know, aqua-ish color. Do you guys agree with me on this first top one, number 1, that my slope is -2 and my y-intercept is at -1?
Yes.
Okay. So I'm going to go to -1 and put a point. And then my slope is negative. That means my line is going to go that way. So I'm going to go down 2/1. And I have a line. Again, I like to use dotted lines because I like to erase. Some people, see here when I did this, they said, oh my gosh, this is so much easier than last year. Some people told me, this is confusing the way you do it. Then do what makes sense to you. I'm just trying to show you what I think is the easiest way. But if this is not the easiest way for you, then do it your own way.
I got a question.
Yes, ma'am.
Is it possible? Okay.
Yeah. If that saves you time, Deanna, that's fine. I personally like to just draw it all out and then erase. But that's just me.
Where are you? Like, what is this?
This is the piecewise number 1.
Piecewise.
So I'm going to look where Deanna was just saying right here. That's our boundary line. So 2. I'm going to go right here. I'm going to draw a line at 2 where X is 2. And this is telling me that they want all of the values, right? All of the values where X is less than or equal to 2. Would you guys agree that this side of the line where I colored in is where X is less than or equal to 2?
Yes.
Yes? Okay, so then that means I want everything on that side and I'm going to erase the stuff over here. What kind of a dot do I have at this boundary line?
Open.
Look at it.
Close because it still exists.
Close because it's got that or equal to sign
The
underneath,
line.
right?
Yeah.
Okay, and then I like to erase this. It's easier on Notability because you can just get it to go away, but on Explain Everything it's a little more difficult. So you guys get what I'm doing? All right, now I'm going to take that pretty teal color, right? And you guys are going to tell me my slope is what?
-1.
Perfect. And my y-intercept is at?
+4.
Okay, so I'm going to go to 4. And -1 means it's still going to slope the same way. So it's going to go like this. Draw my line. And in this case, my boundary line happens to be at 2 again. So I'm going to draw it 2. And I want all the numbers that are greater than 2. Would you agree with me that this side of the number line is where x's are greater than 2?
Yep.
So anything on that side is what I want to keep. Everything else I want to erase. Now again, if you're like Deanna and you can just see that before drawing half the, you can just draw half the line, feel free, go for it. I just don't see it that well. What kind of a dot should I have at 2?
An open circle.
Good. Why is it open?
Because there's no line under the.
Because there's no
greater
line
than.
underneath. Good. Good, 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 good. All right. We feel okay?
Yeah.
Yep.
All right.
I
Let's.
feel like I did something completely wrong.
Why? All right. I stopped recording on this one. So we drew our line here. Our y-intercept was at -2. My slope was 1. And I want only stuff in between -2 and +2. That's why we kept it. But if you notice, the first parameter right here with the green gave me a closed dot. So that's why the second one gave me an open dot. If there's an open dot on top of a closed dot, it's closed. So you guys don't have to have like 2 different dots. You don't have to have like this open and closed next to it. They overlap. That's why it's like that. Now the last one, my slope is what here? -2. And my y-intercept is at 4. So I go up here to 4. -2 means I go down 1, over 1, down 1, over 1. +4. -2 is my slope. So yeah, it should go down this way. And they want me to look where all the values of x are greater than 2. So here's my line. And all the values of x that are greater than 2 are on this side. So I'm going to keep this stuff and do what with the other stuff?
Erase.
Good. And there I have my cool piecewise function. Isn't it neat the way that it looks? It's the coolest thing you guys have ever done.
For the blue line, it's you don't have to put like any circles at the end, right?
No, because it's all kind of stuck together. Just
Oh, okay,
one
so-
continuous, yeah.
It's a continue. Okay, thank you.
Yes.
Wait,
So
so,
then-
isn't the pink line going towards the negative numbers though?
It's going towards negative on the y-axis, but not on the x.
Oh, okay, thank you.
Mm-hmm.
So then the blue line would have all filled in circles, or the middle be like an open circle.
Was that us?
Yep.
End up having closed circles on both ends, even though it's open and open on its actual thing. Since the one above it and the one below it are equal to, then it's got everything on it.
Okay.
Okay, look. I'm putting this on the video so you guys can watch it, or look at it, but I also posted this in modules. So you guys are free to go into modules. This is the 1, 1, 1, 2. It's everything all worked out. So you can check your 1, 1, 1, 2 stuff. If you have any questions, let me know. Email me tonight. We can talk about it tomorrow before we start class. And then I will post this video as soon as we're done